Okay, friends, today we're going to be talking about chapter 6.3, which is complex rational expressions. So essentially what this is two sets of fractions divided by another set of fractions. So they're complex because there's two levels of them, but they're also connections of rational expressions, hence the name. Now, I think that's kind of a difficult name to use, and so I like to call them double-decker fractions. And that's what we'll call them throughout the class. So what we're going to talk about today is how to solve these double-decker fractions. Now they look kind of challenging, but they're actually not that difficult. We solve them similarly to how we've solved other things. So we're going to use an example, and this is one from the book. It's 1 plus 2 divided by x divided by 1 minus 4 over x squared. Now, what I want you to do, this is the first method. What I want you to do is just look at the top. Just look at the top, 1 plus 2x, and I want to put those two together. So I'm not even pretending that the bottom exists right now. I'm just looking at the top, 1 plus 2x. It's a pretty simple problem. I know that I need to have a common denominator. I don't have a common denominator. I can rewrite this as 1 over 1 plus 2 over x. My common denominator between 1 and x is, of course, x. And so I'm going to rewrite this to be x over x plus 2 over x. And that makes sense because x divided by x is 1, which is what we started with. Now, if I look on the bottom, I'm going to recognize the same thing. That's 1 over 1 minus 4 over x squared. And then I can say that that's x squared divided by x squared minus 4 over x squared. And that makes sense. Now, I'm going to rewrite it, but I'm going to rewrite it as one big fraction over another big fraction, which just means that I combine the tops, making sure to distribute my negative properly, or watch my signs. So if I rewrite it, it's going to be x plus 2 divided by x all over x squared minus 4 divided by x squared. Okay, now this is similar to 6.2 when we were dividing fractions. Remember, dividing fractions, don't know why, flip the second and multiply. Or dividing fractions, easy as pie, flip the second and multiply. So this equals x plus 2 divided by x times, the bottom goes on the top, x squared over x squared minus 4. And of course we're just multiplying by the reciprocal, and that's what really happens when we divide fractions. So now we're going to look at this, and I'm going to solve it just like I did all the problems in 6.2. So the first thing I'm going to do is factor. Can't factor this, can't factor this, can't factor this, but I can factor this. It's a difference of squares. So I'm going to rewrite it to be x plus 2 divided by x times x squared divided by x plus 2 times x minus 2. Okay? Now at this point, I can rewrite it as one really big fraction. So this equals x plus 2 times x squared divided by x times x plus 2 times x minus 2. Now do you see anything that we can cancel out? I see that I have an x plus 2 on top and an x plus 2 on bottom. That over that, of course, equals 1, so I can bring that out, which is the same as canceling it. Remember, it doesn't go anywhere. It actually just divides itself out to be 1, and that's understood so we don't have to write it. Now, are there any other x minus 2's? I don't see any. And then I have x squared on top and x on bottom. So that's 2 x's on top and 1 on bottom. And so I can take 1 away from the bottom and 1 away from the top, and that leaves me with x divided by x minus 2. And that's my answer. And I can always check my answer by picking a random number. So let's use the number 1. So 1 plus 2 divided by 1 is 2. So 1 plus 2 is 3. Put that in my brain right here. And then I have 1 minus 4 divided by 1 squared is 1. 4 over 1 is 4. 1 minus 4 is negative 3. So it's 3 divided by negative 3, which equals negative 1. Now let's check it in here. 1, that's just 1, divided by 1 minus 2 is negative 1. And is 1 divided by negative 1 negative 1? It is. So I know that I got it right. Now, this is the first method. It makes sense to recap. All that we're doing is adding up the top or subtracting the top, adding up the bottom or subtracting the bottom, all the while finding common denominators, and then dividing fractions, don't know why, flip the second and multiply. Okay, now the second method is a little bit different. I'm going to double check and make sure that you can still see what I'm writing. Okay, so now I have another example. 3 divided by 2x minus 2 minus 1 divided by x plus 1 all over 1 divided by x minus 1 plus x divided by x squared minus 1. Okay, now there's a rule that says I can multiply anything by 1 and it's the same thing. It doesn't change anything. So if I have 6, 6 times 1 is 6, I'm fine. If I have 1/2 times 1 is 1/2 and I'm fine. If I have Mississippi, Mississippi times 1 is Mississippi and I'm fine. So I can multiply this whole thing by 1 if I want, and nothing's going to happen. It's still going to be equal to the expression that I have right here. So what we can do is actually multiply the top by something and the bottom by something that will start canceling things out or reducing the entire equation to something that's more manageable. I'm going to show you something first before we try to solve this. So if I had 1/2 plus 3/2 x equals 7/2. This kind of looks confusing, right? Because there's a lot of fractions, and sometime in 4th grade someone sprung fractions on us when we weren't paying attention, and then ever since then they've been a little bit confusing. But it's really not that hard. We just have to do the work for fractions. But wouldn't it be great if we didn't have to? Well, as it turns out, we can create an equivalent expression that we can solve for x and get rid of all the fractions. So, first thing I do is find out, is there a common denominator? In this particular example, there is. It's 2. So I can multiply the whole thing by 2, and that makes that 1 plus 2 times 3/2 x is 3x equals 2 times 7 over 2 is 7. Doesn't that look a lot easier? Now I can just solve just like that, right? I just put that in there even though you kind of knew what I was doing. So this is the same idea. We're going to multiply every fraction by the denominator, the common denominator, to get rid of all the fractions. I'm going to show it to you in action once, and then I'm going to work another problem that might make it a little bit more clear. So the first thing that we have to do, always, 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 is factor everything, because only then will we be able to tell what the common denominator is. So 3 divided by, I can take a 2 out of there, and that makes it x minus 1. So that's just that to that. Okay? Minus 1 over x plus 1, there's nothing I can do there. Divided by 1 over x minus 1, nothing I can do there. Plus x divided by, this is a difference of squares, so I can rewrite it as x plus 1, x minus 1. Okay? Now, I need to find a common denominator. Remember, when I find a common denominator, essentially I'm looking for what I used to call a boat, or something that will fit every denominator. So I know that it needs to have a 2. I know that it needs to have an x minus 1. So that takes care of this one. Now let's look at this one. I know it needs to have an x plus 1. So that fits. I know that it needs to have an x minus 1. Oh, but I already have an x minus 1, so I'm okay. And it only needs one of these, right? So that's good. I know it needs to have an x plus 1, which it has, and an x minus 1, which it has. So this is now my common denominator. So what I'm going to do is I'm going to rewrite this whole ugly thing, but I'm going to multiply it by this on top and this on bottom. Because you can't just multiply it on top and you can't just multiply it on bottom and still expect it to be equal. So I'm going to show you what that looks like. I'm going to say 2 times x minus 1 times x plus 1 divided by 2 times x minus 1 times x plus 1 times all of this stuff on top. And then all of this stuff on bottom. Okay, so all I did was I found the common denominator by looking at all of these, and I'm multiplying it by everything on top and multiplying by everything on bottom. But really, it kind of looks like this, right? Because this is just one big term that I'm multiplying by this. So it really only affects the numerators. Okay? So that's what I'm going to do. I'm going to distribute it to the numerators. Okay? So let's rewrite that. 3 times 2 times x minus 1 times x plus 1 over 2 x minus 1. Notice I'm not doing any of the math. I'm just writing it all out, right? Minus 2. That 1 is there, but it's kind of holding in place, right? 2 times x minus 1 times x plus 1 divided by x plus 1. All of that over 1 times 2 times x minus 1 times x plus 1. I would do hand stretches before you get to this class because there's a lot of writing going on. But I just multiplied 1 times this, and then I put it over x minus 1. Notice I'm not doing anything to the denominators. That's really, really important. I'm just going to look and make sure. Okay, good. You can still kind of see what I'm doing. And then plus x times 2 times x minus 1 times x plus 1 divided by x plus 1 times x minus 1. Okay, now that was the hard part. That was all the difficult work. Now comes what I think is the fun part, and I think it's the fun part because I'm kind of a big nerd, but I like to clean things up and organize things. And the great thing about this is we're about to get to clean this up quite a bit. So I'm going to look at each separate fraction. There's 4 of them, remember? And I'm just going to cancel out everything that I can. And if you found the correct common denominator, which ours, if you remember, was 2 times x minus 1 times x plus 1, and you'll see it right here, right here, right here, and right here. If it is the correct common denominator, it should cancel out every denominator. Okay, so let's look. I've got a 2 on top and a 2 on bottom. Goodbye. X minus 1 on top, x minus 1 on bottom. See you later. I've got an x plus 1 down here and an x plus 1 right there. Take it easy. I've got an x minus 1 and an x minus 1 right here. Adios. I've got an x minus 1 right here and an x minus 1 right here and an x plus 1 and an x plus 1 right here. Au revoir. Sayonara. So I just got rid of all of my denominators. Now I'm going to collect what I have left and rewrite it. And if you notice, it's not going to have a denominator. So I've got 3 times x plus 1 minus 2 times x minus 1, make sure to watch your signs, divided by 2 times x plus 1 plus 2. Now, I can't cancel these out because they're held together by an addition sign and a subtraction sign. And remember, if they're touching one of these, they're frozen. You can't do anything about it. You're stuck. Now I just need to distribute and make sure I distribute my sign correctly. So 3 times x equals 3x. 3 times 1 is 3. Minus 2x, because negative 2 times x, and a negative 2 times negative 1 is plus 2, divided by 2x plus 2, distributed that and distributed that, plus 2. And then I just add up my like terms. 3x minus 2x, that is x. 3 plus 2 is 5. 2x plus nothing. 2 plus 2 is 4. And that's my answer. Pretty cool, I think. So now I've got to check, right? So I'm going to use 0 because 0 is super easy. And I'm going to plug it in here. And I'm going to say, okay, starting at the very beginning, way up here, what would happen if I put a 0 in for all of these? Well, 2 times 0 is 0. This is going to become 3 over negative 2 minus 0 there, that's going to be just 1, so minus 1. Negative 3 over 2 minus 1 is going to be a negative 5 over 2. Okay, and now let's look at the bottom. If I put a 0 in here, that's going to be a negative 1 total. Plus, put a 0 in here, a 0 there, it's just going to be negative 1. So it's negative 5 over 2 divided by negative 1 equals a positive 5 over 2. Okay, so that's in my brain right there. Now let's do the same thing down here. If I put a 0 right here, that's going to be 0 plus 5 is 5. That's good. And a 0 times 2 is 0 plus 4 equals 4. Okay, now I noticed that it's not exactly right. So that tells me that I've done something a little wrong. It's not the end of the world. We'll still move on. This is why we check our answers, right? So let's go back and see if we can locate what we did wrong. So I'm going to look back. Aha! So if I look back, I'll notice that right here, when I wrote this down, what did I write? I wrote a 2, but what should it be? It should be a 2x. Okay? And that would change this to a 2x, right? And that would make this x plus 5 divided by 4x plus 2. Now if I plugged in 0, that would be 5, and that would be 2, and it works. Now, I am perfectly fine making mistakes and then going back and finding my mistakes, and I think that you should be too. And this was an honest mistake. I didn't do this on purpose to teach a lesson or anything like that. This was a mistake, but because I checked my work, I was able to see that I had a mistake, and then I went through my work more carefully. And that's why it's so important that you check your work. So, and as you can tell, look at all this. There are a lot of steps going on, and so there's a lot of opportunities to maybe make a mistake, and that's why it's really important that you check your work. Now, this was kind of a complicated one. Let's do one that's maybe a little bit easier. This is number 14 from the homework of 6-3. It's 9 over a minus 5 over b divided by 4 over a plus 1 over b. Now, I want to know what my common denominator is. So I'm going to look at all my denominators. First, I'm going to factor it all. Factored, factored, factored. I can't do anything. Now, a and b, a and b. So what is my common denominator? It has to be able to fit a, so I'm good with that one. It has to be able to fit b, so I got to put a b in there. It has to be able to fit a, good, and b, good. So my common denominator is a times b. So I'm going to multiply a times b times everything on the top, which just means the denominators, right? And I'm going to multiply it by everything on the bottom, which is just the denominators of what's on the bottom. So this becomes 9ab over a minus 5ab over b divided by 4ab over a plus ab over b. And now comes the fun part. Cross out the a's, cross out the b's. Cross out the a's, cross out the b's. And notice how all of my denominators have been crossed out. That means I chose the correct common denominator. And then I'll rewrite this as 9b minus 5 divided by 4b plus a. I put negative 5a. Remember, you need to take your time when writing this because sometimes when you cross things out, it's really easy to forget something that's there but you didn't cross out. So this would be my final answer because I can't factor anything. Let's do one more just because I can tell that you guys are loving this. Y over y squared minus 1 minus 3y over y squared plus 5y plus 4 divided by 3y over y squared minus 1 minus y over y squared minus 4y plus 3. Okay, first thing that I need to do is factor everything. So this equals y over y plus 1, y minus 1, minus 3y over y is up front, 4 and 1, both plus signs, divided by 3y over y plus 1, y minus 1, minus y divided by y is up front, minus 3 minus 1. Now, I need to find what my common denominator is. I know that it's going to have a y plus 1. I know it's going to have a y minus 1. I know it needs to have a y plus 4. It already has a y plus 1, so I'm good there. It needs a y plus 1. Got it. A y minus 1. Got it. A y minus 3. Oh, I don't have that. And then a y minus 1. Got it. Okay. Now, I'm going to do something a little bit tricky in that what's going to happen is I'm going to multiply this on top. But instead of rewriting the whole thing, I'm just going to write it really small next to this. Okay? So watch this. Y plus 1, y minus 1, y plus 4, y minus 3. Y plus 1, y minus 1, y plus 4, y minus 3. Y plus 1, y minus 1, y plus 4, y minus 3, y plus 1, y minus 1, y plus 4, y minus 3. Now, can I cancel things out? Yes. Y plus 1, y plus 1, y minus 1, y minus 1. And then y plus 1, y plus 1, y plus 4, y plus 4. And then these guys again. and then a y minus 1, and a y minus 3. So I can rewrite it as, and I'm going to look at what I have still here. I'm going to rewrite it as y times y plus 4 times y minus 3 minus 3y times y minus 1 times y minus 3 divided by 3y, y plus 4, y minus 3 minus y, y plus 1, y plus 4. Now, in this situation, I would like to get rid of all that I can. Okay? So first I'm going to see if I can factor anything out of the top or factor anything out of the bottom. So look at the top. I could take out a y out of both of these and a y minus 3. And that would leave y plus 4 minus 3 times y minus 1. Okay? Then I'm going to look down here and see what I could take out. And I could take out a y and a y plus 4. And that would leave me 3 times y minus 3 minus y times y plus 1. Another way you could do this is just FOIL and distribute this, FOIL, distribute this, FOIL, distribute this, FOIL, distribute this, and then add up all your like terms. This is just an alternative way to do it. And then I see that these y's cancel out, so I don't have to worry about those anymore. So now this is y minus 3 times y plus 4 minus 3y plus 3 divided by y plus 4, 3y minus 9 minus y squared minus y. Okay? Now, oh, that was silly of me. I made another mistake. This should just be y plus 1, because I already took this y out. So this should be minus y minus 1. I'm telling you, these videos are killing me. Here we go. So, but it's okay to make mistakes. Math is not about doing everything perfectly. No one's ever a perfect mathematician. We're all in a learning process. Minus 2y plus 7 divided by y plus 4 times 3y minus y is 2y, negative 9 minus 1 is negative 10. I'm going to FOIL these, so that makes that negative 2y squared plus 6y plus 7y minus 21 divided by 2y squared plus 8y minus 10y minus 40 equals negative 2y squared plus 13y minus 21 divided by 2y squared minus 2y minus 40. And that is it. There's nothing that you can do more. And you can actually leave it just in this if you want. Hold on for one moment. So you could leave it like this, or you could rewrite it all factored out to where back to here it's y minus 3. Then you take out that negative, 2y minus 7, divided by, take out that 2 from here, y minus 5, y plus 4. So I wanted to show you that these are three alternative ways of writing the answer. This is completely factored. This is separated, but there's still some factorization that can be done. And then this is completely FOILed out as two trinomials, a rational expression of trinomials. This would be the best answer because it's all factored out. So you don't even have to worry about this all the time. So that is a brief overview of 6.3 and hopefully helps you in understanding how to do some of these. But as a reminder, first step is always to look at the double-decker fraction. Look at signs and look at each fraction. Okay? Next is factor everything. Okay? Third is find a common denominator for all four fractions. Fourth, multiply this denominator by each numerator. So whatever you get for the common denominator, you multiply on the top of every fraction. And then simplify. And that means cross out if you can. Okay? And then add like terms, clean up, further factor if needed. And then the other method, this is what your book calls method 2. The other method is just to find one, solve the top. Solve, I mean simplify. Simplify the bottom. Flip the bottom and multiply. Cancel what you can. And that's it.